Hey class, you should have your workbook and your textbook and a piece of paper ready. We're going to go over your homework and look at the chapter wrap up in your text. And then I'm going to give you a couple problems to try out before we meet at either 9:30 or 10:10. So I'll see you in a few minutes, and you should have watched all of this first. So I'm going to quickly go over your homework in your workbook, 185 through 188. You probably figured out this was Yellowstone before even filling the numbers out, but that was the answer for that little puzzle. And you can see I didn't even fill out some of the other ones because they were so obvious. Page 186, you can see the answers should be 288 milliliters, 315 milliliters. I think we did those two together actually. And then 23 is 1 liter, or 1,000 milliliters. 24 would be 1 liter, 8 milliliters. You could also write that as 1.008 liters. Same thing for 25, 1 liter, 458 milliliters, or 1.458 liters. And then 26 is 1 liter, 456 milliliters. Number 27, it's 1/3 full, so immediately you should recognize the height of the liquid is 3 centimeters. So 3 times 6 is 18, times 12 is 216, so 216 milliliters, or centimeters cubed. Either of those units would be good. And then 28, the height of the total thing is 6, the liquid is 4. It's asking us for this section that's left. So the clever strategy here would just be to find this section, which is 18 by 12 by 2. So I did 2 times 12 is 24, multiplied that by 18, and got 432 milliliters more of water, or centimeters cubed of water, either way. And then the homework you turned in should have been 4 liters, 250 milliliters. I did that one mostly with you. I do know these were challenging, and some of you missed them, so if you did miss it, try to find your mistake, and I encourage you to check in with me if you have any questions. This would be similar to that previous one. The height is 2 centimeters, so 2 times 28 times 20 would get me 1,120, and then add the 1 liter, 400 milliliters, would get me a total of 2,520 milliliters, or 2 liters, 520 milliliters. 31, the height here would be 9.5, because that's half of 19. You could do 14 times 14 times 19 and then divide all that by 2. Or I did 14 times 14 was 196 times 9.5 and got the answer of 1 liter, 862 milliliters. And for 32, the height would be, it says half filled, so 6 centimeters. 12 by 12 by 6 would get me 864. And then the volume of the smaller container here is going to be 560, 56 times 10. So subtract the 560, and I end up with 304 milliliters of liquid left in that container. All right, so open your textbook to the chapter wrap-up. We're finishing this unit up here, and we are going to have an assessment on it soon. Let's review the big things that we should have learned. You should understand that there are different types of solids, triangular prisms, rectangular prisms, a square pyramid here. We talked about drawing different prisms on grids, and actually we also talked about drawing them on regular paper. We talked about nets and the fact that the nets can help you to find the surface area of prisms and pyramids. We specifically talked about cube nets and looked at a variety of different types of cube nets, and talked about the fact that cubes are easy to find the surface area of because we can just find one square and multiply that by 6 since they're all the same. The net of a triangular prism has 2 triangles and 3 rectangles. Surface area requires more steps to get the answers. You got to do it carefully, organized, one step at a time. It's not like volume where you can just do the length times the width times the height. You need to find the area of each surface and add them together. Volume of a solid is, of a prism in particular, is a shorter skill, length times width times height. We're looking for the number of cubes. And we did some practice finding the volume of some prisms and recognize that milliliters are equal to cubic centimeters. So we can write our answer for liquid as milliliters. I also want to highlight that volume of a prism is length times width times height, or I talked with you about the fact that it's also the area of the base times the height, okay, for all prisms. That's the formula for prisms in general, not just rectangular prisms, and I want to build on that idea in just a second. So I'm going to have you do some of the chapter review test here in a moment after we get together. But your problem I want you to try before you meet with me today here is I want you to try these 3 problems. So if you need to, you may need to pause to write them each down. And we're going to go over these live in a couple minutes. But I want to see if you can find the volume of a triangular prism, understanding that prisms are the area of the base times the height. Okay, so you should be able to get that. See if you can figure that one out. One step further, what about a cylinder? A cylinder is just a circular prism, and the area of a circle is pi times the radius squared. Don't know if you can read it, but the radius here is 3. And the height is 10, and I'm reminding you that we can use 3 for pi, an approximation for pi. So see if you can figure that one out. The area of the base times the height. So we can find the volume of a cylinder. And then finally, what do you think about the height of a pyramid? If we were at school, we'd do a little exploration to figure out what the height of a pyramid is. But I'm curious to hear what your guys' ideas might be for this. It's not going to be the area of the base times the height. It's going to be different than that. And without my telling you exactly what the formula is, we'll see if any of you guys have an idea, and we'll talk about it in a few minutes. So give those a shot, and I will see you soon, and we'll talk about the chapter review.